Henry Park 2024 prelim paper for P6, paper 2. Question number 1. PQSU and QRTU are rectangles where PQ is 12, QU is 15, and UP is 9. Find the length of QR. Okay, QR is this question mark over here. Firstly, what we can find is the triangle of PQU. Okay, let's do that first. Triangle. PQU will be half times base times height. So half times 12 times 9, which is 54. Now this is 54 square cm. Now this is actually half of the rectangle PQSU. So this is also 54. And if you notice, right, QSU is actually half of a rectangle QRTU. Okay, so this part here is also 54, which means that rectangle QRTU is 54 times 2, which is 108. Now, because the length of this rectangle is 15, right? So to find the breadth QR, we take the area, which is 108, divide by the length, which you will get 7.2. 7.2 cm. Okay, question 2. Average of 4 whole numbers is 281. Two of the numbers are 371 and 109. What is the smallest difference between the remaining two numbers? Okay, so 4 numbers, the total. Let's find the total using the average. So 281 times 4 first. So this is 1124. Out of this total 1124, right, we already know 2 of the numbers, which is 371 and 109. So let's take them away first. This will give us 644. Now from here, because the two remaining numbers, right, you want the smallest difference, the smallest possible difference between the remaining two numbers will be 0. Okay, which means that the two numbers will be equal. Since it's even, you can divide by 2 equally. Okay, the smallest difference is 0. The two numbers would be 322 and 322. Take note, the question didn't say different numbers. So it can be repeated. It can be the same number for the last two numbers. Question 3, Amy used 7 identical rhombuses to form figure A. Beth added 2 more to form figure B. Now, perimeter of A is 156. Find the perimeter of B. Okay, so what we do is we're going to compare the perimeter of A as well as the perimeter of B. Perimeter of A. From this end here to this end here, right, that's three sides. Then from this end here, because these are all rhombuses, the sides are all equal. Here, this is another 3 sides. Okay, so the perimeter would be here, here, and here. This one, this, and this. Okay, on the other side will be here, this, and this. Okay, you get a perimeter. Then on the other side is this, and this, and this. Okay, so total 4 times 3 sides. Okay, so 3 times 4, which is 12 sides. So 12 sides gives us 156, which means that one side of the rhombus would be 156 divided by 12. which is 13. Now let's look at figure B. Figure B, if you look at this here, this is 3 sides. Now on the other side here to here, this has a total of 5 sides. Okay, 5, that's a 5. So total sides for figure B is 3 plus 5 plus 3 plus 5. Okay, because on the other side, there are also 5 sides, and this here will be 3 sides to form the parameter, the push-out method. So here are 16 sides. This is what we want. Okay, so 16 times 13, which is 208. So answer 208 cm. Okay, question 4. Piece of paper in the shape of an isosceles triangle, PQR, is folded along the dotted line ST. Okay, this is ST. So you're supposed to find angle X. Now, this paper is folded, right? So this 28 degrees goes up. That would be a 28. And because this is isosceles triangle, so this part here is also 28. So now, what I'm going to do is to find this part here. Okay, so that's 180 minus 98 minus 28, which is 54 degrees. So this is 54 degrees. Now, if you were to unfold it, right, it will go back to a straight line, and this would be 54 as well. Okay, which means that I can find this angle here. So 180 minus 54 minus 54. That's 72 degrees. So now I can find angle X. Okay, sum of angles in a triangle is 180 minus 72 minus 28. Answer 80 degrees. Question 5. Danny and Eric started jogging from point A to point B at the same time. Both did not change their speeds throughout. After 20 minutes, Danny was 200 meters behind Eric. When Eric completed the remaining distance of 5 km, Danny was 600 meters away from point B. What was Danny's jogging speed? So let's draw it out. You have point A, point B. After 20 minutes, Danny was 200 behind Eric. Okay, so let's say 20 minutes. Eric is here. Danny maybe here. Okay, he's 200 meters behind. So when Eric completed the remaining distance of 5 km, so this is 5 km. So when Eric completes the distance of 5 km, Danny was 600 away. Okay, so Danny is here. So maybe up till here. This is 600 meters. Okay, not really drawn to scale, but yeah. Okay, what was Danny's jogging speed? Now, this 200 meters, right, is the difference that of what they traveled, of what they jogged in 20 minutes, okay? Because this difference came up after 20 minutes. So the difference between what they can cover, difference in distance, in 1 minute would be 200 meters divided by 20 minutes. Okay, so that's 10 meters. So every 1 minute, Eric would cover 10 meters more than Danny. Okay, then now let's look at what Danny covered. Danny covered 200 plus this part here. And this part here is 5 km minus 600. Okay, so Danny covered 200 meters plus 5,000 meters minus 600 meters. Distance covered by Danny, 200 plus 5,000 minus 600, which is 4,600. Then we find the distance covered, okay, sorry, you don't need to find, but the distance covered by Eric is 5,000 km, right? So what is the difference? Can you see I'm trying to use like the difference in 1 minute? Okay, so what is the difference in distance covered? So the difference in distance covered would be 5,000 minus 4,600, which is 400 meters. Okay, so how long does it take for Eric to cover 400 meters more? Every minute he covers 10 meters more. So the time taken for that to happen would be 400 divided by 10. Okay, 40. This is in minutes. So that whole thing took place in 40 minutes for Danny to travel from here all the way to here. It took 40 minutes. And here all the way to here is 4,600 meters. So his speed, Danny's speed would be 4,600 divided by the time taken, which is 40 minutes. Okay, so it's 115 meter per minute. All right, so we use the difference in distance to help us solve the question. Question 6. At first, Jason had $210 and Ruth had $154. After they both spent an equal amount of money, the amount of money that Jason and Ruth each had was in the ratio 7:3. So how much did each of them spend? Okay, let's show using a before change after. So J is $210. R is $154. There is a change. John spent some. Sorry, not John. Jason. Jason spent some. Ruth spent some. In the end, the ratio is 7:3. So in this question here, what doesn't change? If they spend the same amount of money, it is the difference that doesn't change. Okay, so we find difference. $56 is 4 units. Because the difference is 4 units. And we find 1 unit, which is 14. How much did each of them spend? Okay, you can find, let's say we find Ruth lah, since it's a smaller number of units. 3 times 14. You can find Jason also, no problem. So Ruth has $42 in the end. How much did she spend? So you find the difference between at first and in the end. Okay, so 154 at first, minus away 42 in the end. That will give us $112. Question 7. Graph below shows the number of muffins a bakery sold each month from May to December. So we're supposed to find the average from May to August. May to August. Okay, let's write down all the numbers first. For May, take note that this is 0 to 150 in 5 intervals. So each interval is a plus 30. Okay, so for May, this would be 750 minus 30. For June, it's 600. July, 600 minus 30, 570. August, 420. September, 480. Then 330. 270, 150. But we only want May to August for part A. May, June, July, August. 2310 in 4 months. So 2310 divide by 4. 577.5. Okay, so the answer 577.5 for part A. Now for part B, based on the number of muffins sold from October to December, the bakery wants to increase the number of muffins sold by 30% in the 3 months of the next year. What is the targeted total number of muffins to be sold in the next 3 months? Okay, so let's add up first October to December. 330, 270, and 150. This will give us 750. This is the original, which is 100%, okay? Because you compare it against this, and then there should be a 30% increase. So you want to find a new number. You find 1% first, so you divide by 100, you get 7.5. So for next 3 months of the next year, right? There's a 30% increase, so we are looking for 130%. We're not looking for the increase, we're looking for the new number. So 975. Question 8. 4 children received their scores for a quiz. Ariel scored 8x. Bella scored 12 more than Ariel, so it's 8x plus 12. Number of points Bella scored was half of Charlene. So Charlene would be twice of that. Okay, we double it. 16x plus 24. Okay, then Daryl is 7. So for part A, this is the answer. You've completed the table. For part B, find the total score when x is 15. Okay, let's add them up in terms of x first. 8x plus 12, 16x plus 24, and then plus 7. So when you simplify this, all your x get together. Oops, no. So this will give us 32x. And then when you add the rest of the numbers up, you will get 43. So now you replace x with 15. So that's 32 times 15. Then add 43. This would be 523. Okay, so answer for part B, 523 is the total score. Question number 9, Janice drew and shaded a large semicircle. and small, okay, sorry, Janice drew and shaded a large semicircle and a small semicircle on a rectangular piece of paper of length 24 cm. The diameter of the large semicircle is twice that of the small semicircle. Find the total area of the unshaded parts of the paper. Okay, so the diameter of the big one, the big semicircle, is twice of the small one. So I can say that this one is 2 units and this is 1 unit. So 24 would be 3 units. We take 24 divided by 3, which is 8. Now from here, we can actually find the diameter of the big semicircle as well as the small semicircle. Okay, sorry, we should be finding radius since we are finding area. Okay, so the area of the small semicircle would be 8 divided by 2. Okay, radius of small semicircle would be 8 divided by 2. Okay, 1 unit divided by 2. Now the radius of the big semicircle, since the big semicircle is has a diameter of 2 units, the radius would be 1 unit, right? So 1 unit is just 8, so radius is 8. Now we are going to find the area of the 2 semicircles and then we'll remove it from the rectangle. But for the rectangle, what is the breadth? Okay, so the breadth of the rectangle is made up of this, and this is actually the radius of the smaller semicircle, which is a 4. And from here to here, that's the radius of the bigger semicircle, which is 8. All right, that's how we get the breadth of the rectangle. Okay, semicircle, half times pi, which is 3.14. We're using 3.14 for this question. And times the radius times radius. Okay, so this is 25.12. Then the big one, right? Half times pi times 8 times 8. This is 100.48. Rectangle would be 24 times 12, which is 288. Now you just minus off. Okay, rectangle minus the 2 semicircles. And you will get 162.4. That's the unshaded part that we want. Square cm. Next question, question number 10. Boxes A and B contain an equal number of coins. 1/4 of the coins in A are 10-cent coins, while the rest are 50-cent coins. 1/3 of the coins in B are 10-cent coins, while the rest are 20 cents and 50-cent coins. Okay, so in box A, you only have 10 and 50 cents. In box B, you have 3 different types of coins. For part A, given that the total value of all the coins in A is 86.40, find the total number of coins in box B. All right, so let's look at box A first. They tell us we know the fraction, right? And the fraction is talking about the quantity, the number of coins. So for box A, for the 10-cent coins to the 50-cent coins, I'm going to use a quantity value table. In terms of quantity, you have 1/4 that's 10-cent coins, which means 3/4 would be 50-cent coins. Okay, then next, the value of each coin. For 10 cents, it's just 10 cents. For 50 cents, it's just 50 cents. Then total value would be 1 10-cent coin, 1 times 10 cents. 3 50-cent coins would be 3 times 50 cents. So let's give it 150 cents. Okay, so this is your one group in box A. because they tell us the value is 86.40, right? Using this grouping, quantity value is grouping. So in one group, the amount of money that we have would be 10 cents plus 150, which is $1.60. Okay, then from here, we have number of groups, which is 86.40 divide by 160. That will give us 54 groups. If there are 54 groups of coins, we're looking for the number of coins in B, right? And they contain the same, A and B. So you can find the total number of coins in A, and that will be the same as B. So we take 54 times 4, because in every one group there are 4 coins from quantity. So answer 216. For part B, total value of all the coins in B is 5010. Find the number of 20-cent coins in B. Okay, so in B, earlier on, we read that we have 1/3 10-cent coins and the rest are 20 and 50-cent coins, right? So let's focus on the 20 and 50-cent coins, which we don't know how many are there. Okay, so let's find out. Sorry, I mean, we don't know how many of each are there, but let's find out just between 20 and 50-cent coins, right? What's the total number of coins? So total number of coins in B is 216, 1/3 10-cent coins, so 2/3. This is the number of 20 cents and 50-cent coins. 2/3 of 216, which is 144. Now there are 144 20 and 50-cent coins, but I don't know how many of each are there. So let's do supposition. Okay, wait, sorry. You need to find the value of the 20-cent coins and we move it from 5010 first. So number of 20-cent coins would be 216 minus 144, which is 72. Now the 72 20-cent coins would be 72. Sorry, not 20-cent coins, but 10-cent coins. 72 10-cent coins, 1/3 are 10-cent coins. Okay, so 72 10-cent coins is $7.20. Now the value of the 20 cents and 50-cent coins would be $50.10 minus $7.20. So this will give us $42.90. Okay, from here we'll do a supposition. Starting with, since we're looking for 20-cent coins, let's suppose all are 50-cent coins. And when we say all, we're looking at 144. So the total value would be 144 times 50 cents. This will give us $72. Then the extra that okay, the value that we have is 42.90, right? The extra that we need to remove because now it's too high will be 72 minus 42.90. This will give us $29.10. Then from here, we look at one exchange because there's too much we need to exchange. Not all of them are 50-cent coins. So in every exchange, it goes down by 30 cents, which is the difference between the 50 and 20-cent coins. Okay, so 30 cents is the difference. Now the number of exchanges, right? Sorry, 30 cents is not the difference. 30 cents is the amount it decreases by whenever you exchange one time. So the number of exchanges will depend on how much you want to remove. The extra that we have is $29.10. So we'll take $29.10 divide by 30 cents. This will give us 97 exchanges. 97 is the number of exchanges from 50 cents to 20 cents. So you're putting in 20-cent coins 97 times. So there are 97 20-cent coins. Question 11. Mary and Gary each bought 2 items at a store during the sale. Okay, Mary bought 2 different bags. The original price of one of the bags was $280, while the original price of the other bag is $499. How much did she pay in total for both bags? Now, according to this discount, right, if you only buy one item, it's a 40% discount. If you buy a second item, you get 50% off just the second item, on top of the 40% for the first item. Okay, but the thing is that the second item should be the cheaper one. Okay, it's either equal or cheaper. So identify which one's your first, which one's your second item. Your first item would be the more expensive one, $499. So the amount that you're paying would be 60% since there is a 40% discount. Okay, so 60%, which is 60 over 100, of $499. This would be $299.40. The second item is 50% discount. So 50% times $280. This will give us the amount that she paid for the second bag. So now add them up. And you will get 439.40. Okay, that's the amount she paid for both bags. For part B, after discount, Gary spent $1,669.80 on 2 identical watches. Find the price of each watch before discount. Okay, if there's 2 watches, they are both at equal price, right? The discount on both will be different. So let's say original price is 100 units now. Okay, let's use units. Then the first watch would be gotten at 60 units. Second watch of the same price would be purchased at 50 units since it's 50%. So the amount that he pays, right, would be 60 units plus 50 units. So 110 units is what he paid. So 110 units is 1669.80. Then we find 1 unit. So 1669.80 divide by 110, which is 15 0.18. Each pair before discount is 100% or 100 units. So we times 100. Okay, you get 1518. That's the amount paid, $1,518.
For question 12, shops Q, R, and S sell ice cream in two sizes, either the small or the big tubs. A small tub of ice cream is sold for 12, big tub sold for 18 each. So the table below shows what each shop sells, but for shop S, the numbers are covered by ink blocks. Okay, so for part A, what is the total amount collected by Q and R from the sale of small and big tubs of ice cream? Okay, let's group the small tubs together and the big tubs together, then find out what's the cost from there. Okay, so for the small tubs, right, it's 15 plus 10, which is 25. So 25 small would be 25 times $12. This will give us $300. Okay, that's for this part here. Then for the big tubs, we're looking at this. So 9 plus 15, which is 24. Now 24 big tubs will be 24 times $18 because each big tub is 18. This would be $432. Okay, you want to find the sum, so we add them up. $300 and $432. Okay, so answer for part A is $732. Now for part B, shop S sold as many tubs of ice cream as Q, but collected $66 more. So how many small tubs of ice cream did shop S sell? Okay, so we're comparing S versus Q. They sold they sold the same number of tubs. The total is 24. So shop S also sold 24. But I don't know how many small and how many big. So what I'm going to do now is using shop Q, right? 15 small and 9 big. I'm going to try and reconcile this difference of $66. Okay, so shop S sold same number of tubs, but it collected $66 more. So what we know is that shop S actually sold more of the big tubs compared to the small tubs. Okay, by selling more big tubs, shop S can collect more money. So I'm going to start with 15 small and 9 big. And we are going to swap every small for every big. Okay, we're going to swap until the difference becomes 0. Now the difference is $66. So every small, so one exchange, one exchange. This is from one small to one big. The difference is between 18 and 12, which is $6. So every time I swap from one small, I remove one small, I add in one big tub, I get an extra of $6. But shop S is extra $66. So the number of times I do this exchange, right? Number of exchanges will be 66 divided by 6. Okay, we're doing this 11 times. So 11 is the number of times I'm swapping from small to big. If I do it 11 times, then I'm actually taking away 11 small. Question is asking how many small did S sell. So definitely not 15. Every time we convert, we're reducing the small. So we do it 11 times, means that 15 minus 11. Okay, so the number of small tubs by S will be 4. So small was 15. Every time you exchange, you reduce by $6. So you're going to reduce it. You increase by $6. You need to increase by 66. So you do it 11 times. That's why the small becomes 11 lesser. Okay, so answer 4. Okay, next question. Question 13, the printing rates of 3 machines ABC are shown. At 11 o'clock, Gwen started to print posters using only machine A. Half an hour later, while A continued printing, she started printing posters with B and C as well. So how long would B and C take to print the same number of posters as A? Express your answer in hours and minutes. Okay, so firstly, A started first, right, for half an hour. Let's find out what's A in half an hour. In 30 minutes. So A in 30 minutes. Or half hour. So it's a 360 divided by 2, which is 180. Okay, so A started with 180 at first. Then when B and C started printing, right? Okay, the question is asking for B and C, asking how long it will take for B and C to print the same number as A. So for B and C to print the same number of A means that there is a like a catching up to do, right? Because A already started with 180. Okay, let's find what is A and B combined. So in 1 hour, B and C in 1 hour. B plus C in 1 hour. So we're finding like the combined rate first, since both started printing together. This is 410. So in 1 hour, B and C can print 410 posters together. Now, you know A started first. A had a head start of 180, right? Do you think B and C can ever catch up with A? The answer is yes, because if you compare in 1 hour, right? If you compare B and C, they can print 410. But for A, it prints 360. So there is a chance for B and C to catch up to be the same as A, right? So in 1 hour, the extra that B and C can cover, can print. So we're looking at the difference. Difference in 1 hour would be 410 minus 360. So every 1 hour, B and C can catch up by 50 posters. But the extra that B and C needs to catch up by is this 180 that A started with. So how long does it take? So time taken to catch up by 180, right, would be 180 divided by 50. Because 180 is the total that it needs to catch up with. 50 is what it can catch up with within 1 hour. So by dividing this, you are actually finding the number of hours. So this is 3 3/5 hours. Then this is the time taken. They're asking for the time taken. So this is the answer, but you need to express it in hours and minutes. So 3 3/5 would be 3 hours. 3/5 hour, you have to change to minutes by multiplying it by 60, because every hour is 60 minutes. Okay, so 3/5 times 60 is 36 minutes. So this is the time taken for them to print the same number. Okay, this is the time taken for B and C to catch up with A. So yeah, in other words, it's printing the same number of posters. Question 14, we have figure X showing a rectangular block of wood, length 78, breadth 39, and you have figure Y here. Okay, from the block of wood, Kevin cut out a stand, which is this, with identical steps on both sides, as shown in Y. Each step measures 6 cm in height and 9 cm in length. what is the height of the original block of wood? Okay, so the height of the original block of wood, right, would be this here. Okay, so all the steps are like 6 cm tall. So that's actually 6 cm times 4. So 4 times 6 is 24. So the height would be 24 cm. Okay, 24 cm. Find the volume of the block used for figure Y. Okay, so what we want to do is to remove all the, imagine there are rectangles that are being cut out. So what it looks like from the side view is 4 sides. So 4 steps, 1, 2, 3, 4, like that. Then from the side view, we cut them into rectangles, not squares, but rectangles. Okay, equal rectangles. Then this one, the height of each step is a 6. And the width of this is a 9. So 6 times 9. How many do we have? Okay, sorry. Let's find one of this first. This one, 6 times 9 is this this side, this surface area, but then it has 30 is a 39 cm long stick, okay, or beam or whatever. So the volume will be 6 times 9 times 39. Then on one side of the step, there's 1, 2, 3, 4, 5, 6. There's 6 of this. But then you also have the other side, right? So that's another 6. So you can just times 12. 106 times 12. Okay, there are 12 of those sticks. 25,272. Now, if you take all these and remove it from the original cuboid in figure X, right, then you get the answer for the remaining volume. So for figure X, the cuboid would be 78 times 39 times 24. 73,008. Then minus away the parts that are taken out, which is the 25,272. Okay, you get 47,736. So this is the answer, cubic cm. Okay, question 15. In the figure ACDE, it's a rectangle. CDF is an equilateral triangle. Okay, let's mark that out. CDF. CDF. Then we have isosceles triangle ABE, for which the sides are already marked as equal. And we have 15 degrees BCA, AFD 170, AB is parallel to FC as marked out. Okay, so first you need to find AFC. This is 60 degrees. This is also 60. This is 60. So to find AFC over here, we can use angles at a point. Angles at a point is 360. So 360 minus 170, then minus 60. Which is 130 degrees. Okay, next one, find angle AEB. AEB, okay, this angle marked out here. So this is an isosceles triangle. If you want to find this angle, you will need BAE. So BAE is made up of this 90 degrees, right? Plus BAC here. BAC here. And you see there are parallel lines. So actually you can use the alternate angles if you know this angle ACF. So let's find ACF. ACF is the fastest way would be to use, because this is a rectangle, so this is 90 degrees, 90 minus 60. $30. So over here we have 30 degrees. Okay, then alternate angles. Which is this. And it works because you have parallel lines like that. Which means that this is 30 degrees. Okay, then you have right angle here. So BAE is 90 plus 30. $120. If BAE 120, you can find AEB, which is what we want, since we have isosceles triangle, which is 180 minus 120, 60, then divide by 2. Okay, so 60 degrees divided by 2. So answer 30 degrees. Questions, oh, sorry, part C, circle the words that describe ABCF correctly. So, they're asking if ABCF is a parallelogram. ABCF, is this a parallelogram? If this is a parallelogram, that means AF and BC are parallel, right? If they are parallel, these two angles here should add up to 180, but they do not. This one is 45 degrees. 45 plus 130 is 175, not 180. So it is not a parallelogram because AF is not parallel to BC. Okay, AF is not parallel to BC. Because if it is, then this plus this would be 180. But this plus this is 175. So it's not. Okay, we're using like interior angles to help us. The one that looks like a U. Okay, next question, 16. Joanne completely packed 2 types of boxes, large and small, with identical bottles of oil. So in these boxes, there are bottles of oil. After she packed 14 large boxes and 18 small, completely with 1914 bottles, she had some remaining. So she could not completely pack another large box with the remaining bottles, as she was short of 15 bottles. But instead, she completely packed another small and had 12 bottles left. So how many bottles did she have? Okay, from this part of the question, right, sounds like there is a shortage, there is a surplus. So it's a shortage and surplus kind of a question. Okay, let's draw a model. So there are 2 different scenarios, right? One if she packs small, pack the remaining into large. The other is if she packs it into small. Okay, but 2 models for 1 scenario each. But the thing is, there were 1914 bottles that have already been packed, right? So those are let's remove them first. So let's say that 1914. 1914. These are packed into 14 large and 18 small. Now, whatever that's left behind, if she packed into large boxes, she would be short of 15. Short of 15 means you need extra 15. So you add on 15 here. 15 bottles. So this is for one large. That's the number of bottles needed for one large. But instead, she packed it into one small. But if she packed into one small, she would have 12 left. So 12 is part of this original. We cut out 12. So this is for one small, okay, without the 12. So from here, ignore the 1914 first. If you compare one large, one small, right, the difference is actually 15 plus 12. Okay, so difference between one large and one small be 12 plus 15. Okay, 27. So every one large is actually the same as one small plus 27. Now, let's go back to the 1914. In 1914, there are 14 large and 18 small. What I want to do is I want to convert the large to small. So there are 14 large bottles. I will find what is 14 large bottles. So I basically times 14, which is 14 small, plus, then you key in what's 27 times 14. 378. Okay, so we multiply by 14. That's how we get this. So 14 small and 378 plus 18 small will give us 1914. Okay, so I mean this one is your 14 large, right? Plus this one. So 18 small plus 14 small plus 378 equals to 1914 bottles. And when you combine this part here, that's 32 small. And now we find what is 32 small. Which is 1914 minus 378. 1536. From here, you can find one small box, which is 1536 divided by 32. So every small box, there are 48 bottles. How many bottles did she have? If you look at the model, right, 48 is over here, this part. So the total number of bottles would be 1914 plus 48 plus 12. And this would give us 1974. Okay, so answer 1974 bottles altogether. Okay, question 17 is a pattern question. Jaya used gray and white squares to form a figure below to form a pattern. So you have a table here. Okay, let's look at the next part here. Jaya used 1004 white squares to form a figure. What's the total number of white and gray? Okay, so we are given the number of white. We're supposed to find white and gray. Let's get a pattern. So for the number of white, It's 4, 8, 12, 16. These are actually multiples of 4. Multiples of 4. What about total number of squares? Now, use the diagram to help you deduce this. If you look at the total number of squares in each diagram, right, they actually form a square. So this should give you a clue that we're talking about square numbers. Okay, square numbers are like something times something. So how are these? Are these square numbers? Yes. Let's say for 9, 9 is 3 times 3. And this is 4 times 4, 5 times 5, and so on. Okay, then this here is a multiple of 4. So 1 times 4, 2 times 4, 3 times 4, and so on. So if it's 104 white squares, right? Let's find the figure number. They divide by 4. 1004 divided by 4. So figure number is 251. If it's 251, what is the total number of squares used? It is not 251 times 251 because figure 1 is not 1 times 1. Figure 1 is 3 times 3. Figure 2 is 4 times 4. Figure 3, 5 times 5. It's always a plus 2 and then you multiply it by itself. So figure 251, you need to add 2 first. Which is 253. Okay, so from figure number, you add 2, then you multiply it by itself. So 253 times 253. $64,009. Okay, that is the total number of white and gray. Okay, for part C is a little more challenging. In the table above, so the above table, the difference between the total number of squares used in X and Y is 497. Find the value of Y. Okay, so X and Y are consecutive numbers. So the difference in the number of squares used here is 497. So plus 497. So we need to use 497 and figure out what is this, the pattern numbers and find the value of Y. Okay, what's the pattern here when you increase? Let's look at increase. This one increases by 7, then by 9, then by 11. The intervals always increase by 2. Okay, so let me write out here. So for figure number, they 1, 2, 3, 4, and so on. And then until figure X, figure Y. The total number of squares will be these. Okay, then now the increase here. So this is basically what I wrote earlier. Just write it here easier to see. Yeah. Plus 497. Okay, then you see every increase here, there is an increase of 2 for each interval. Right? This will be the interval, which is not a constant number. It keeps increasing by 2. So firstly, what we want to do is, so now we're like looking at another set of pattern. 7, 9, 11, all the way to 497. So first we take 497 minus the first number, which is a 7. 490. Okay. So I take this this interval here, I minus away this first number here, I get 490. 490 will be all my plus 2's. So I'll take 490 divide by 2, which is 245. So there's actually 245 times of this plus 2. Okay, 245 times of the plus 2. So to go back one step, how many intervals are there? We take 245, add 1. Okay, the number of intervals. So the one I circled, the intervals I'm referring to that. Okay, the number of intervals will be 245 plus 1. Two, 4, 6. So the one in blue, there are 2, 4, 6 number. Then you go back again, you want to get a figure number, right? From intervals, 2, 4, 6 intervals, right? To get a figure number, there's actually one more. So you need to add 1 more. 2, 4, 6 plus 1. Okay, it's kind of like layers of intervals. Okay, so that's how you get the figure number 247. This is the last figure number. This one, this is 247. If they want x is 246. Okay, but you want the last one, figure value of y. Okay, so for with that's the end of this paper. This is for Henry Park paper 2. Right, Henry Park. Yeah, Henry Park Prelim paper 2 2024.